Hello everyone. Welcome to another exciting session on exploratory data analysis using Python. Well, my name is Rajan Chetri, and in today's session we'll be covering one of the most important aspects of any data science enthusiast, and that is EDA. So before we get started with EDA, let us try to understand what exactly we'll be covering in today's session by following the agenda here. So in today's session, I'm going to give you a brief understanding of what exactly exploratory data analysis is. Once we are clear with EDA, we'll be going through the various steps that are a part of EDA, and basically they clear the roadmap of how the EDA should be performed. Once we understood the steps properly, we will be seeing the implementation of those steps in a case study in today's session. Alright, looks like we are pretty excited to get started with EDA. So let us start with the introduction first of all. Well, when we talk about EDA, it's about, it's not about data science, it's about decision science. Yes. So here we are talking about making decisions based on the insights that we gain from the data. Well, in order to gain insights from the data, we have to, follow a process, and that's what EDA is. So what exactly exploratory data analysis is? So if we want to explain EDA in simple terms, it means trying to understand the given data much better so that we can make some sense out of it. Well, technically in statistics, exploratory data analysis is an approach to analyze data sets to summarize their main characteristics, often with some visual methods like plots or graphs. A statistical model can be used or not, but the primarily EDA is for seeing what the data can tell us beyond the formal modeling or some basic hypothesis testing task. EDA in Python uses data visualization, which is an important aspect of any EDA, to draw meaningful patterns and insights from the data. It also involves the preparation of data, which we call data pre-processing, for analyzing by removing some irregularities or anomalies from the data. So that is basically a basic understanding of what EDA is. Once we're clear with EDA, once we are done with the EDA, we'll be able to draw the insights, we'll be able to take the decisions later or further. Before we proceed further, understanding what are the various steps in exploratory data analysis, let us try to understand the need for the exploratory data analysis. Now, exploratory data analysis is a crucial step before you jump to machine learning or modeling your data. By doing this, you can get to know whether the selected features are good enough to model. Are all the features required? Are there any correlations based on which we can either go back to the data preprocessing step or we can move on to the modeling? Once exploratory data analysis is complete and insights are drawn, its features can be used for supervised or unsupervised machine learning models. So, how do we get started with exploratory data analysis? Well, there are various steps in exploratory data analysis in Python. What I'm going to do is I'm going to write it down some basic steps that are basically a part of every other regular EDA. Well, the description of the data is something to be analyzed when we are working on a given data sets. When we are provided with any data sets, we are supposed to handle the missing data. Once we have handled the missing data, the third parameter is basically handling the outliers. Once we have handled the outliers in a given data, the next step is basically to understand the relationships and new insights through plots. So basically, these are the generalized steps, when we perform during the EDA process when provided with some given data. Let us understand all these steps more in detail in the upcoming slides. Well, when performing EDA, the very first step that we perform, is to understand the data first of all. So, with every given data set, you are going to be provided with a data dictionary, which is going to explain the various features or the attributes of the given data. So, it is going to explain the various columns and their purposes. If there are any values like 1 and 0, it's going to explain what does exactly it means. So, before you get started with any EDA process, the very first step is to understand the structure or the metadata or the schema of your data. Once you have understood the schema properly and clearly, the very first step that you are going to perform is to import the data into Python. And yes, we're going to use pandas mostly for that. So here, this implementation is referred and is implemented using pandas only. So the very first step that we'll be doing is importing the data using pandas, and the data can be in various formats. It can be in Excel format, it can be in a CSV format. So that entirely depends on what type of data set you are working on. Once you have successfully imported the data using pandas, what the next step that you are supposed to do is you are supposed to check the structure of your data. So it is basically a normal routine check, and this in this check you're going to basically verify what is the shape of your data. You're going to verify the various information provided by the data. You're going to check the description or describe the data. You're going to check the missing values percentage. So that is something that you can check. You can check for the cardinality of the data by using an unique function available in pandas. So here, once you have loaded the data successfully, the next step that you should be doing is basically checking the structure. And in context to pandas, you can check for the shape or info, describe. You can check the missing values. You can check the number of unique values in each column. So this is a initial routine check that you're supposed to do on the data. Once you have checked the structure properly, the next step is basically the data quality check or checking of missing values. Well, there are various things that we can do in this section or in this category. We can check for the percentage of missing values in the columns if we have any. So we are supposed to observe which columns are basically having less percentage of missing values and which columns are having high percentage of missing values. So if we find that if there is any column with high percentage of missing values, what we can do is basically based on the relevancy of the column, we can either include it or mostly we can remove it from the data frame or from the data, so that we only work with the relevant features or relevant attributes in the given data frame or in the data set. Once we have identified the columns with the missing values, and once we have removed the column or we have imputed the values, we are supposed to check that if there are any columns with less missing percentage. All right, let us say somewhere around 10% missing values are there in a given column, or let's say some 15% missing values are there in a given column. What we are supposed to do is basically we are supposed to find the approach of handling those missing values. So what is the best suitable way to handle those missing values? If it is a categorical column, right, can we fill it using some value, some default value? For example, let's say if there's a column called language with various languages and there are some missing values, can we fill the missing values using English? Or let us say if there is a numerical column or a categorical column, can we impute or fill the values using the mean of the column, or we using the mode of the column, or the median of the column. So can we do that, right? So or just we can simply, you know uh, we can simply fill the values using 0. So that will entirely depend on the context of the data, and its features. So these are the various techniques that we can use for handling the missing values. This will entirely depend on the learner's understanding that how they are going to handle it. Once we have done the data quality check properly and the missing value treatment properly, the next step is to basically check the data type of the columns. So this is very important. So when you load any data in pandas, many a times you will find that not all the columns are loaded properly. Generally it has been observed that you know uh, let's say the datetime columns are loaded as object types or string types, for just for easy understanding. So what we are supposed to do is that we are supposed to convert the columns into their appropriate data type. So let's say if the column is date time and it has been loaded as an object, so we are supposed to convert it into date time. Or let us say if the column is numerical, but it has been again loaded as an object due to some missing values conversion error, then we are supposed to convert it into numerical type, whether it is integer or float. So these things are supposed to be taken care. Again, before we use the data for modeling in machine learning, we are supposed to check for the outliers also. Outliers are basically those values which are beyond the normal range. So whether those values are right, or whether it's a human error or some algorithmic error, so whether those values require any treatment or not. So these things are supposed to be considered while performing EDA on any given data. Then finally, for gaining insights from the data, for a clear understanding of what data is telling us, we can also follow one more concept in EDA, and that is binning. Now, binning is basically a simple process of converting any numerical column into a categorical column. So I'll just give an example here. Let us say let's take an example of temperature, right? Let's take an example of temperature. Let us suppose that we have some values here. Let us say 5, uh, 37, and let's say 89, and let's say -2. All right, let's say we have some numerical values here, and what binning says that we basically convert a numerical column into categorical column. So what we can do is we can populate or generate a new column here, let's say called level, and let us say the temperature range between 1 and 10 is very cold. The temperature range between 10 and 20 is, let's say 10 and 25 is, let's say, just cold. And the temperature is, let's say, from 26 to, let's say, 35, we would say, let's say, warm. And the temperature range, let's say, less than 0 is chilled. So what we can do here is that we can categorize these values as per the given range here. So this will be very cold, this will be hot, let's say, this will be very hot, and this will be chilled, let's say, or extreme cold, right? We can say anything. So here you can see that out of this numerical data, I have just populated one more you know uh, column here, which is a categorical column, and it has the values as per the range we have specified. So this is an example of binning, which can help us plot various information, like these are the values under the very cold, and these are the cold, and this is the hot, and this is the extreme cold. So this is how we can gain more insights. This is how we can produce the information which is simplified and easy to understand. So that this is the whole process of data quality check and handling the missing values, and what are the various operations that you can do with the given data. All right, now once we have done the data quality check properly and handling of the missing values, the next step that we are supposed to do is basically checking the imbalance percentage in the data. All right, so here we're supposed to check the imbalance percentage. Now you must be wondering what exactly imbalance percentage is. Let's take an example from the present situation of, let's say, COVID. So let us say if we try to determine what is the COVID percentage, uh, among the gender, let's say, right? So if we, let us say, if we gain the insights, if we draw the insights that the male percentage, let's say 85%, and the female percentage of COVID affected patients is 15%, let's say. So this is called data imbalance. Basically, the ideal balance percentage is always between 50% and 50%. So this is called a balance percentage, but here we can see the imbalance here. Now whenever we see imbalance, it doesn't mean that it is negative, right? Or is it positive? So its interpretation will entirely depend on the data, right, on which we are working on. So let us say if the loss is there, so we want, if the comparison is between profit and loss, we surely want the profit percentage to be on the higher side, isn't it? So basically imbalance is just for understanding the behavior of the data, or what kind of pattern that the data is presenting to us, right? So based on the imbalance percentage, we try to interpret it. Once we have done the imbalance percentage analysis, the next step is to perform the analysis. Now here, before I tell you the points here, basically analysis can be of univariate types, it can be of bivariate or multivariate. So if you are new to these terms, like what is a univariate, bivariate and multivariate, it basically means that how many variables or how many attributes you are taking into account for performing the analysis. For example, let us say if you are only taking one uh, attribute, right, only one variable for analyzing the data, so that is basically uh, univariate analysis. So if you are taking two variables, let's say profit and budget, so that's basically bivariate analysis. And if you are taking multiple variables, like some variable here, some here, and some here, all right, so x, y, and z, so this is a multivariate analysis. So here, once you have done the imbalance percentage analysis, you're supposed to perform univariate analysis on categorical variables. Once you have analyzed categorical variables, you're supposed to find the correlation between the numerical columns, like demand and supply. Let's take an example of demand and supply here. So you're supposed to figure out, right, so is there any correlation between the demand and supply? Is the relation positive, is it the negative, or is it the neutral relation? So that's something we are supposed to figure out. Once we have done these analysis, we'll move on to check the variables with the highest correlation, and that is going to be the foundation of our EDA, right? So in the EDA, variables having the highest correlation are suppose positive correlation, I would say here, will be taken into account for further analysis. After this, we are supposed to perform the univariate analysis on numerical variables, and bivariate analysis on numerical variables. So ultimately, univariate, bivariate on both categorical and numerical variables will be performed. All right. So once you are thoroughly done with the EDA process based on the recommendations that are given in this video, you will be able to draw the insights from the data and gain the information. Let us try to understand the EDA process that we have just discussed using a case study here. Now, the case study that we're discussing here is about a customer churn. Now, customer churn is basically connected with the telecom industry or the telecommunications sector. So, here, customer churn basically means the customers who are leaving or porting out of this telecom sector, maybe to a different network provider. So it's like porting out. Now here we are supposed to figure out why the customers are porting out from the existing company, from the existing telecom provider. Now the telecommunication sector has become one of the main industries in developed countries. The technical progress and the increasing number of operators has raised the level of competitions. Now, companies are working hard to survive in this competitive market depending on multiple strategies. Customer churn is a major problem and one of the most important concerns for large companies. Due to effect on the revenue of the companies, especially in the telecom field, companies are seeking to develop means to predict potential customers to churn. Therefore, finding the factors that increase customer churn is important to take necessary actions to reduce this churning. Let us try to understand the implementation of the EDA that will help us understand the customer's churning behavior based on the various features or variables. So let us try to understand this customer churn case study. All right, let us start with the customer churn case study here. In this case study, we will try to implement all the steps that were explained during the presentation in the video. So let us start with the customer churn case study by importing the libraries first of all. The libraries which are required are pandas, matplotlib, and seaborn. Let us do some configurations here which will make us understand the output properly. All right. So we have loaded the required libraries here. Once we have loaded the required libraries, the next step is basically to load the data. The data that we are working on is telcochurn.csv. So let us create a data frame here and use the read CSV method to load the data. Here we have successfully loaded the data, and let us have a preview of the data here by calling the head function. Now this is a preview of the data here. Now this telco churn is easily available over the internet, or you can refer to the Kaggle platform for accessing to get the access of this data. It has various attributes in it. So let us go through the various attributes of this particular data. Here we have customer ID, gender, senior citizen, partner, dependent, tenure, phone service, multiple lines, internet service, online security, online backup, device protection, tech support, streaming TV, streaming movies, contract, paperless billing, payment method, monthly charges, total charges, and churn. The most important attribute here is the churn attribute. When it says no, it basically means that the customer is a part of the same network provider, the original network provider. When the value of churn is yes, that basically means that the customer has left the network. Let us do some descriptive analytics and let us try to understand the nature of the data by using some built-in functions which are provided. So here we will be doing a small routine check here on the data frame by calling the info function. Now this info function provides us with various details here. So let us observe the details. So there are total 21 columns here. There are 7,043 entries within this given index range. The type of the data is data frame. There are various columns here. There are total 1 float 64 columns, 2 int64, and 18 object type columns. The current memory usage is 660.3 plus KB, and there are various columns here with their data types. Now there is one thing that we are supposed to observe here is the total charges. If you observe the total charges here, the total charges is a numeric column here. But when we look at the type of this total charges, it says object. What we are supposed to do is basically we are supposed to convert the type of this column, total charges, from object to numeric. To be precise, float 64. The reason for converting this column into numeric type is so that we can perform the analysis on this data and we can compute this data mathematically. Let us try to convert this total charges column into numerical type. For that, we have df total charges dot as type function. Let us say we are trying to convert this column into float type. Here we can see that we are getting an error here. Now the reason for getting this error might be weird or complicated. Let's try to figure out why we're getting this error. Here we can easily determine the reason for this error by the value counts method. Now if you look at this value counts method here, you can see that there are some missing values here. There are a total of 11 missing values, and the as type function is not able to convert these missing values into float type. This is the reason for getting the error in the previous code. In order to handle such situations, we have some alternate solutions available in pandas. So here we'll be using pd.toNumeric method. Now pd.toNumeric method is one of the alternate methods that we can use for data type conversion. Here it is going to accept the total charges as the parameter here, and there is one more parameter called errors. Now the value of this parameter is coerce. I'm going to explain what does coerce means. Coerce basically means that if there are any missing values, those are supposed to be ignored. Once the data type conversion is completed, the total charges will be updated. Let's try to execute the following code and let's check the information once again. If you observe here, we are able to convert this column from object to float 64 by using this alternate solution. Now once we have completed the routine check, let us do some analysis on the data. Let us analyze the data using various analysis techniques here. So the data analysis that we are going to perform on the data is going to be of univariate analysis and bivariate analysis. Now the univariate analysis can be done on categorical column or the continuous column. At the same time, the bivariate analysis can also be done on continuous column, continuous categorical, and categorical column. So here, this should give us or provide us with the basic understanding of in what various ways we can perform analysis on the data. Let us try to analyze the customer churning from the given data frame. Now, the strategy that we'll be following here for analyzing the data is basically separating or partitioning the data based on the churning here. We are going to create two data frames here. One data frame is going to contain the data for the customer who have not churned, and another data frame who has the details of the people who has churned from the telecom provider. So here we are going to create df underscore 1 equals to df churn yes, and this is going to contain no. Now here this df underscore 1 is containing the data for only those customers who have churned from the telecom provider. Df underscore 0 has the records where the customers are still the part of the company. We are going to analyze their habits of monthly charges or total charges, their gender, the various features here to determine the patterns or to identify the patterns in these two types of customers. So first of all, let us do univariate analysis on the data, and here we are going to plot monthly charges. So we're going to observe the behavior of customers based on their monthly charges. So here this is non-churn, which is 0. If we look at the output here, if you look at the plot here, it is very easy to determine the patterns between the customers who have churned and non-churn based on their monthly charges. So if you look at the churn here, the customers who are churning most are between the range of 60 to 120 here. So this 60 to 120 monthly charges is the segment of people who are leaving the company. So one of the factor here, the monthly charges between 60 and 120. But if you look at the non-churn segment here, the most of the people lie in the monthly charges of 0 to 40 here, right? Not exactly 0, but somewhere around 5 to 40. So this basically tells us that the people who are having higher spending on their monthly charges are more prone to leaving the company or are more prone to churning. But here only one factor should not be taken into account while making any decisions. There are multiple factors to it, and that's why we have bivariate analysis also. So this is one of the basic example of how we perform the EDA, how we see the patterns or the trends in the data, and how we can draw some insights or inferences from the data here. Let us look at another example, and in this example we'll try to understand the customer's behavior based on their contract type. So here we have uh, a column called contract, and here we have some values here. What kind of contract people are having with the company, whether it is month to month, 1 year, or month to month once again. So let us write the code here. Here I have prepared the data already, and let's try to observe the contract type. All right, so there is some error here. Okay, I think the error lies here, dot py plot. So that is something to be corrected. All right, df underscore 0. So here we have another plot here, plot using univariate analysis based on the contract column. So here we are supposed to observe the pattern in the contract of the people who have left the company, who have churned, and those who have not churned. So if you observe here, we see that the people who are in the month to month contract with the company are basically having a balance here. Not exactly, it cannot be the reason for churning, but the people who were in the 2 year contract are actually churning from the company here. And here in the non-churn also, there are a lot of people who are having the 2 year contract. So this is not really showing any strong pattern or any relation in the people who are leaving the company based on the contract type. So this is more of a kind of uniform understanding. Let us perform a bivariate analysis, and using bivariate analysis, let us try to draw some insights from the data. For performing the bivariate analysis, we are going to compare contract and the monthly charges of the people from both the data sets, from df1 and df0. That basically means those who have churned and those who have not churned. So here let us plot a box plot here. Sometimes it is also called whisker plot, which is basically used for bivariate analysis here to find the pattern in the data. So let's construct the code here. Fix size and comma 5. So I'm just using the subplot here. This is going to be churn. So here we are using box plot here, where in the x-axis we'll have the contract, and in the y-axis we'll have the monthly charges here, and the data is coming from df underscore 1. Similarly, we are plotting another box plot here. The title of that box plot is going to be non-churn, and the box plot is again going to have contract at the x-axis and monthly charges at the y-axis, and the data is going to be coming from df underscore 0. All right, the h is missing here. Okay, so if we look at this plot here, if we look at the box plot here, what we can interpret from this data, from this plot. So there is one thing that we can clearly observe from this box plot is that the people who are churning from the company are always at the are always at the higher side of spending the money on their network charges. So whether the people are from, let's say, month to month contract or 2 year contract or 1 year contract, if you look at the quartile range here, they are spending more than 50 or 60 dollars or whatsoever in the monthly charges. Whereas if we compare the non-churn segment of the data, we see that the people are having you know uh, the uniform spending habits here, right? So they're not spending too much on their monthly charges, whereas if you look at the medians here, so the median is nearly same for every contract type, whether it is month to month, 1 year contract, or 2-year contract. So once again, the insights that we can draw from this plot is basically the people who are spending a lot on their monthly charges are more tend to leave the network. All right, let us perform one more plotting here, one more analysis, and this time we are going to observe the trend in the churning of the customers based on the genders here. Now, once again, this is going to be a bivariate analysis, and this in this bivariate analysis, we are going to compare the people's contract type with the company against the gender. So we are trying to figure out whether the gender is playing any role, in the people who are leaving the company. So let us try to find the pattern based on these two parameters here, contract and gender, and this is going to be the bivariate analysis. So in order to gain the insights from this bivariate analysis, we're going to plot a count plot here. So let us start writing the code here. Fixed size 10 comma 5 subplot, this is going to be 1 2 comma 1 plt dot title churn sns dot count plot. So at the x-axis we are going to have contract, and the hue is based on gender, and the data is going to be retrieved from data frame 1, and the palette is going to be set 1. This is basically the color scheme. Plt dot subplot 1 comma 2 comma 2, title is going to be non-churn, and sns dot count plot. Once again, we are plotting one more count plot here. The x-axis is going to have the contract, and the hue will be again based on gender. Data is going to be retrieved from data frame 0. So okay, so here we have this plot here. So if you observe this plot here for the churn and non-churn customers based on the gender here, right? So this maroon color is representing the male and this blue color is representing the female. Let us try to find the pattern. So if you look at the pattern here in the month to month, there is no variation between the male and female. So this is near to equal. So there is no difference in the pattern of the gender. So even if you look at the 2-year contract, or if you look at the 1-year contract here, it looks like the male and female both tend to leave the network, equally. So there is no imbalance in the data. Whereas if you look at the non-churn segment here, again we see a uniformity in the data. There is not such high imbalance, and it looks like both the male and female tend to tend to be a part of the network, no matter what kind of contract they are in. So whether it is month to month, 1-year contract, or 2-year contract. So as per this analysis, we find that gender is not having a strong positive relation with the churning rate. So gender is nowhere near affecting the churning of the customers. So this basically confirms that whenever there is a new subscriber who is subscribing to the network, most probably the gender is not going to play important role if it's going to determine if it's going to leave the network or not. All right. So that was an implementation of EDA techniques on customer churning, data analysis. So basically, we did not only find the various features which are going to greatly impact the customer churning, but we also identified that which customers are most likely to abandon the company. So churn rate is a health indicator for any subscription-based company. The ability to identify customers that aren't happy with the provided solutions allows business to learn about products or pricing plan, weak points, operation issues, as well as customer preferences. So this EDA basically helps the companies or the decision makers to understand what measures needs to be taken uh, to for their customers, to keep them within the company or to keep them paying to the company. Well, that's all folks for this video. I hope you have clearly understood the various aspects of EDA and the various techniques used to gain the insights from the data. I hope this helps all of you. So if you have liked the video, please do not forget to subscribe to the channel, hit the like button and press the bell icon. Thank you for watching the video. I'll see you in my next video session. Take care.